Live streaming is on.
Hey guys, so another week, another sync. Let's start with the same old intro round as last week at least. Just kind of interesting thing you learned about cadCAD and intentions for the call. Or didn't learn about, interesting thing you learned about something related to this project. So interesting thing I actually already put in the Telegram notes or chat room that there's like this AI dungeon choose your own adventure story that is also using Google Colab. I haven't gotten to really dive in to see how they make it usable, but I mean, it's being linked in all sorts of interesting popular articles, and getting a lot of play. So I bet we can learn a thing or two from what they're up to. And intentions for the call, really just to see what you guys want to talk about and have more of a collaborative agenda setting round to kind of. I kind of imagine maybe we'll want to go through the code and talk about things in more of a free form discussion. But we'll see how it goes. Either way, hoping that you guys can set the topics. I will pass it to Nelson.
Hi. Um, so this week I didn't really learn anything related to cadCAD, but I managed to kind of stabilize my situation so I will have more time to work on it. I posted some questions and I added some inputs and outputs. And I guess my objective for this call is to go a little bit deeper into that, kind of explain what I meant and see what everyone's thinking about what's possible, if it makes sense. For preview, I kind of think like a lot of the concept that we use are very math and financial world heavy. And I kind of like wanted to make it more, let's say, a normal person that has a use case, kind of like trying to input some stuff without having to understand the science behind it deeply. That's it. And I will pass it to Javi.
To who? To Ravi.
Yeah, I think you're muted, Javi.
Yeah, he's at work. Maybe he cannot.
I said, well, go for it, Sam.
Okay. I just installed cadCAD in my computer because I saw that in Google Colab there is something broken with the importing of the configuration. So I just wanted to try it on my computer, and it was kind of easy. It's just P3 cadCAD and install other requirements, and it works. And one of the things that I've also learned about is that, well, it's still I still have lots of questions about how the simulation works and all that, but I understand much more things now, and I see that cadCAD is run in for 3 simulations, and the only thing that changes is the alpha. There are 3 alphas. One is 50%, the other is 80%, and the other is 90%. And we just explore one of the last one with the 90% alpha, which is the graph with the 3 lines and one red line that represents the price. And well, I have been looking at those things, and I still don't understand very much, but I'm beginning to understand much more. I hope that you also can help me with understanding on that. Okay. I will pass it to Griff. What did you learn, Griff? Or you already said?
I already went, and I mostly just learned that there was another project using Google Colab, and I wanted to see what their front end was. But I'll pass it to Jay.
How's everyone doing? My name is Jay Rush. I learned that you can download a Jupyter notebook into Microsoft Visual Code, and you can run it from there. And that involved, I'm not real great with downloading and installing software and getting it to work. I usually give up about a third of the way through. And this seems to have worked, but now I just opened it again today and now it's not working. So I did see it actually working on my machine, which is good for me because I like to play with code. So I like to change things and see what effect it has and so forth. So, and I don't really know Colab well enough, but it felt like I was editing a live document there. So, so I learned how to bring a Jupyter notebook down. And I spent time looking at words. I was telling you last week that I like these words, and I see that there already is a glossary in that document that you have. And I want to compare it. So I made a list of all the words that I encountered that were brand new words and thoughts. And I want to compare that to the list that's already in the document so I don't duplicate. But I'm going to put any new words into that document. So I learned one word from Jeff Emmett. It was, I'll look it up. I can pass it on to someone else, I guess, whoever wants to hear it.
I think that's everyone, actually. Let's see. Yeah, we got a tight crew tonight. It's like no James, but he might show up. We'll see. Cool. Can you guys hear me now?
Yes.
Yes. Okay. Sorry, I'm in like a really nice house with just mediocre at best internet. I'm really sorry about that. But yeah. So this time I want to set the agenda in more of a popcorn style. So basically, if you have an idea on how to spend the next 40 minutes, or a piece of it, just kind of like say 5 words that describe your idea and the amount of time that it'll take. It can be less than 5 words as well. It just can't be 10 because I can't type that fast. So, so if you guys have a topic for this call that you guys want to attack, just say 5 words and the expected time requirement.
I'd like to start the conversation by saying the words that I found so that as other people talk, we can relate to the words that are in the documents that I found. And okay. I'll basically just read the words. You don't have to write anything down.
So read the words. Yeah. And how long do you think it'll take to do that?
2 minutes, 3 minutes.
3 minutes, okay.
For me, it will be input, outputs, and possibilities. What's possible with this?
And how much time?
And
oh, sorry, Nelson. How much time do you think?
no.
How much time it will take? I don't know. I have literally no idea. It might be quick. I guess if one of us have answers, it might be super quick. Let's say 5-10 minutes and see how it goes from there.
Perfect. Sorry, Sam.
I'm not sure about that because I barely understand the simulation, but we may go through the simulation and and see what everything does. Or maybe we can do it next week, and we already know more things of it. I don't know if it.
No, I mean, I think
We can start with that this week, and if we don't see how it works, we can move it to the next one.
okay. How long do you think it will take to go through the simulation?
I think 15 minutes.
Okay. Any other agenda topics? Okay. Oh, sorry. Sorry, I thought I interrupted someone. Okay, well, let's start with Jay and Nelson. I think that going through the simulation might inform your one, so we'll just put some before, if that's okay.
Yeah, I agree. It will be connected.
Yeah.
Okay, so Jay, do you want to read the words?
Yeah, I'm just going to read words, and I don't really know what a lot of them mean, but I mean, they're all familiar words, but in this context, they have different meaning. So I'm also trying to group them a little bit. So I'll just read a group and then a bunch of words and then another group. So in what I'm calling it, like the group about commons, we have altruism, collective needs, commons, realigning incentives. In governance, we have community governance, conviction voting, DAOs, escrows, futurarchy, polycentric governance, proposals, public goods, quadratic voting. In common stack, we have common initiatives, community deployments, continuous funding, CSTK tokens, exit tax, field test commons, giveth dApps, minimal viable commons, proposal engine, source credibility, token engineering, trusted seed. In ABC, which I think means augmented bonding curves, you have funding pool, hatch phase, initial allocation, which is fee, initial price P0, initial raise D0, initial reserve R0, initial spot price, initial supply, open phase, reserve pool, token lockup. And now you can kind of get the idea of why I think words are kind of important, because there's a lot of different words in here. Systems design, there's words like biomimetic design, which is simulating life, cadCAD conservation principles, complex systems, ecological economics, intersystem feedback, mechanism design. Blockchain related stuff is analytical dashboard, forking, XDAI, and then some other words: bounty networks, C organizations, Harbinger tax, microeconomics, and then lastly, we have Ponzi schemes in here. Okay. So I don't know. I mean, those words are just crazy. So anyway, I think that's part of the fun is new ideas. So that's great. I'm finished.
Cool. Well, cool. Yeah. I mean, geez, there are a lot of crazy words. That was like buzzword central all in one. I feel like we should just turn that into a Common Stack commercial right there. I feel like the Fairwind video. Anyway.
Like the Radiohead song with the robot voice saying just words.
Yeah, exactly.
Great.
If you guys didn't see the Fairwind video, it's worth it. It's worth it.
And then just repeat it on a loop. Repeat it on a loop.
Yeah, it's a cool background. Well, cool. Obviously, I think a glossary is needed.
Yeah, I do. And they're all sort of familiar words, but they have kind of different contexts, different meaning. So, yeah.
Well, I think the next agenda topic is just going through the simulation, which is probably something we should have done by now. So it's good that we're tackling it. Did you want to
Okay.
lead some?
Yeah, I'd like to share my screen. Let's see. Okay. As well, here at the beginning, we have a description of cadCAD is and the way that we can install it. We don't need anymore this part here because cadCAD is now open source. So actually, we don't need that token anymore. And the first thing after that is the description of the trigger threshold function, which takes these inputs, which is the requested funds, the funds that are already available, the stake supply. Well, the threshold is the function that the conviction have to be up to the threshold in order for a proposal to pass. And it depends of the token supply of stakers, but also the funds that are available and requested. And also there are two static variables which are define the function. So we have this function here, and the first thing that we do is to make this graph, this color plot that relates token supply with the fund requested, and I still don't understand much how this works, but what it does is to use a trigger sweep, which is a function that is defined in another file, and a trigger plotter, and creates this graph. And also, if you use the same function but with alpha and the same trigger plotter, it creates this other graph. I think that those are not interesting for the purpose of this project, because this is not using cadCAD at all. It is just showing how the trigger function behaves. So we can advance on that. Here we define the number of participants, the number of initial proposals, the sentiment, and these are variables for the augmented bonding curve. And we initialize the network here. Initialize network and initialize bonding curve. Okay. So we get all those new variables here that we can check. The invariant should be always the same. This a number that should be constant whatever happens to the system. And it is used in the bonding curve to make sure that there is always the same collateral, the same amount of collateral, so people can, there is not that Ponzi scheme in which people buy tokens at the beginning and then can extract the collateral from the bonding curve. It is better explained in the deep dive bonding curve article, augmented bonding curve article. And later on, there are another graph that shows how this invariant is kind of maintained in the system, which is not that interesting because it will always be maintained if the system works. Later on, we define the set of proposals and the participants, and we set some, in this network, which there is also this graph, we set the supporters and the people who is in conflict with each one. This is also not part of the cadCAD thing. It's something that is set up as the initial value of how will be the network. And I still don't understand it yet. But, well, what it does is to use some functions that are defined in the simulation to make this network, to model this network. And we see how the tokens are distributed among the participants, and also how the funds are requested. And this is the how the participants are affine to each other. I don't know.
So
Yeah.
this one is where like every participant, there's only 3 proposals, and it kind of says how much they like each of the 3 proposals.
Okay, thank you, Griff. And here we set up 2, 5, and 10, and we get 3 alphas from that, which is 0.5, 0.8, and 0.9. So these are the 3 alphas in which we are going to run the simulation. As you can see, it doesn't matter. The important thing is that those are the 3 alphas that we have. We set it in those parameters, and those parameters are quite important. We don't need to modify the parameters on the other files because we already have them here. So if we just want to set up another alpha, we write it here. Well, not exactly here, but we can set up the exit tags, for example. We have here much more things that we can use. And here is the configuration of the cadCAD. And if we ask for the simulation parameters, we obtain this thing, which are the 3 simulations, in which the only thing that is changing is the alpha, as you can see, 0.8, 0.9, and 0.5. So we set up the initial conditions, which some of them are already got from the bonding curve that we set up at the beginning, which is this one. This one is this thing is very important. Initialize network and initialize bonding curve. It sets up all the variables that are used later. So we get the initial price from here and also the initial reserve. And they are set up in those params. Sorry. They are set up in those initial conditions. So, and we set up more things here. So at the end, what we can do is to run the cadCAD, which is, it is done here in run.execute. And we get the raw result for each of those executions, which are 3. Okay? And those executions, if we check at them, we obtain these 3 graphs here. Because Yeah, we got these three graphs here, and we get one of them, which is experiment index. This was initially A2, which is the last one. And we just, from now on, we just go with this simulation, which is the alpha 09, okay? So we set up more things here, and we get this plot with the fund reserve and supply, and also the price per die of X die per token. And this is a boring graph because the supply, reserve, and funds doesn't change so much. But if we change the initial conditions, we can change this graph. And we also, okay, I don't know. We also have those tables here. And this is the invariant thing that I was showing you. It is not going to change so much because it always is going to be on the same line. And also the price curve is quite boring. We have the affinities again. And from now on, those are tests done with what happens with the proposals, and if they reach the threshold or not. Right now, it's not showing exactly the same cadCAD experiment that was before, because I just changed the experiment from 2 to 1, and it shows different data. But more or less, what it does is to show how the proposals are passing which proposals are passing the threshold. So I don't know much more about that. This is just this is what I learned from this. I don't know if you already know that, or you can add more things to this. What do you think?
Well, does anyone have any questions or anything that they want to dive into off that?
I'll jump in. I'm not shy. So this has turned from a big giant wall of impenetrable mathematics into a big giant wall of impenetrable mathematics with charts or something like that. So can I just ask a question or two about this? Like, it's called conviction cadCAD. So and I apologize, maybe I'm behind everyone else, but it's an exploration into how conviction voting works using cadCAD. Is that right?
Yeah.
And
I would go maybe a step further, and it's saying parameterizing conviction voting using cadCAD.
So it's a tool to explore different parameters for conviction voting.
Yeah.
Who wrote it? The people in this call didn't write this code.
No.
Other people or someone else?
Yeah, the block science team wrote it. Andrew and Zargan, but mostly this guy Andrew. I think Ravi is closest with that team.
And to me, I like to get insight into the math with the graphs. I know I haven't really studied the graphs, but is there insight here? Like, where's the insight? What insight am I getting? Can you point to that?
What do you mean insight?
So when I make a graph out of some mathematical thing, I'm doing that because I want to understand something. So are those what would you understand from those charts right there? Is that a reasonable question?
Yeah, very much so.
I think that the graph changes a lot just by setting up a different parameter. The alpha parameter is the decay. Do you remember in conviction voting that the decay is the time that, well, the amount of tokens that you lose each time you don't, well,
Yeah.
I don't know how to explain that.
Yeah.
Do you recall what the decay
Yeah.
was or the alpha was?
Yeah, I do. Yeah.
If we change that parameter,
Okay. So right there, I'm seeing 08 and 05.
Mhm.
And that is the
just by
result.
changing that, yeah, it's
Okay.
or it increases the funds in a steady way, or we just lost all the funds.
Oh, that's so not that's insight. Okay, so that's great.
And is this the funds in the funding pool?
I'm not sure.
No, but that's good. That's what you want to try to, so this chart doesn't really, I mean, it might say that with all those numbers and stuff, but it doesn't really, the insight doesn't come out of the chart, if you know what I'm saying.
Yeah.
So, but that's really interesting if you're changing this one parameter and you're getting such different behavior.
Yeah, and basically what I'm pretty sure these are funding pool funds, and it's basically saying if alpha is 0.5, the funding pool never spends money. But then if alpha is 0.8, this is how the funding pool will spend money. And if alpha is 0.9, this is how the funding pool will spend money.
Yeah, I think that's the thing. Yeah.
Okay. I guess that's kind of.
Just as sorry.
No, go for it.
Just as a brand new participant, a brand new visitor to this space, that's hard to see from here. But I know everybody knows that, but that would be our goal, is to make that come more forward.
That kind of connects to the questions that I had, which would be, how to make it palpable for someone that actually wants to create a fund and see what's happening. Like alpha, theta, kappa is like, I don't know what that means. Like, does it mean that in 6 months I don't have money?
Yeah.
Or,
Well, that's most
like, I don't care about the math. I just want to know, like, are we gonna, if we use that model, are we going to be, if we use that model and we do those actions, are we going to be broke?
Yeah.
Or is it like, is it gonna work? I don't know if someone has something to add to that, or should I start with the question that I had, or what do you guys want to do?
Yeah, I think that we can think about the outputs from the graphs that we have here.
Okay, so let me go back to the document at the same time. So I added a few possible inputs. First, I think a lot of the inputs in the list is like, I have no idea what they means in terms of end result. So there's definitely, we need to do an effort to make that clear for people. And the two inputs that I had was the funds retrieved for project items after the pre-sale. So let's say you start a curve, you do a pre-sale, and you want to have, I don't know, in our case, for example, we need to do renovation work. We have like 80,000 euros worth of renovation work that we need to do. So we ideally, after the pre-sale, we use some of that money for that. Then what's the impact on the curve and the funds? That would be one point. And then also one thing to add would be reinjection of funds per period. Let's say in our case, we rent some office space. we do some kind of work. So we could say, okay, for this fund, we're generating 6K per month or 10K per month. What's the impact? And what's the impact in terms of like, if we put those 10K as purely, we just add it to the collateral, or if we buy 10K worth of token as the association. I guess those are two things that for me just make sense to have as inputs. Are they clear for everyone, or should I explain a little bit more?
But, can you repeat? Or buy tokens or inject
So
them
you
as
could do,
collateral?
yeah, you could do like, I think it was on the continuous organization white paper. There are the difference between the buy function and the what was the name? The re-ejecting. So for example, I could just add the 10K in the collateral, or I could just buy 10K worth of tokens, which would split. Part of it would go to the collateral thing, and part of it would go to the cash reserve. You see what I mean? And then I would get token out of it. So that would have an impact on the supply of the token and on the price.
I think that as the bonding curve is thought, you cannot mess up with the collateral because there is this invariant thing that you cannot extract or add more collateral than what people has. I mean, there are two pools. One is the collateral one and the other is the funding one. And they are very well separated. So the people who buy tokens put their money in that collateral pool in order for the next people who are to avoid Ponzi schemes. I don't know how to explain that, but to avoid Ponzi schemes, we cannot get collateral from that pool, and also there is no point on injecting collateral to it.
I think I agree with the first point. I don't agree with the second one because so basically the name of the other function was dividend. So let's say you have a fund, okay, and the fund is giving is using 10K per month to do something, but that something generates financial value. Then how do you pay back to the people that invested? Is by instead of buying token, you give dividend, which would actually be just re-injecting in the collateral, adding the money, which would raise the price, which was which would create kind of like this circular economy, because every otherwise there's no way to kind of like add back to the fund for the actual project.
But
Do you see what I mean?
I think the issue is that there's I don't know continuous organizations set up perfectly, but I think that they must have different invariants. So we have an invariant where if collateral is injected into the pool, tokens must be created or it breaks.
Okay.
So you could
I see.
still do something like that, for instance, and you could inject inject collateral, which would raise the price. It would also create new tokens, then burn those tokens. You could still do that.
But and I guess you could just buy some tokens, but I think having something a little bit different than just buying some tokens in the case of the actual project that the fund is funding, which would make sense in terms of like incentives for the investors, because they know they get like whatever money is extracted from the collateral, which would put the price down, right? If we take 10K for any project, whether it's one item project or whether it's the running cost of the organization, that will lower the price because that has an impact on the collateral. Am I mistaken, or maybe I'm not? I don't know.
I didn't follow all the way. It would
Yeah,
lower the.
So you have the collateral and you have the cash reserve. If I use some of the money of the cash reserve, does that change the price?
No, so we have a collateral pool and a funding pool, and some has it.
yes, I have it on my screen.
Okay.
They are very differentiated. You can buy with using the bonding curve. You can buy tokens, so it goes to a reserve pool, and also you can burn those tokens that you got, and the same tokens that are here are go outside, and they are a closed system. The only thing is that when you get your tokens back, you pay an exit fee or an exit tax. I don't know how it has been renamed.
We call it exit.
And this is the only thing that goes to the funding pool.
Right.
So each time that you go, you burn your tokens, there is a 5%, for example, that goes to that funding pool. But this is a closed system.
Okay, so it's interesting, and I guess that would be one thing that I learned now, is that each bonding curve scheme is quite different because that's not how they do it. For example, on Aragon Black, the fundraising,
Yeah, they have a tap, which
they have a tap, and also the price is depending on both the collateral and the cash reserve, which is, it makes it hard to understand. Okay, I much prefer this system, to be honest, because then it's clear, like the collateral is one thing and the cash reserve is the other thing.
Sorry, do me a favor. Just again, the circular disc, the thing called reserve bond of DAI, and then the thing called funding pool DAI. You guys are using the word collateral. Which one's collateral?
The reserve is the collateral pool.
And what do you call the other one? Funding pool?
Yeah.
And when you leave or burn tokens, that's when the tax is taken and then it goes into the funding pool?
Yes.
We call it an exit tribute, though.
Exit
tribute.
And then the people are making proposals to spend money out of the funding pool?
Yes. And then actually you can see this big long arrow that goes back in there. The funding pool is held in the reserve currency, in this case DAI, right? And the funding pool will actually send money to milestones or proposals in DAI. But when those proposals are paid out, the DAI is converted into tokens.
I'll have to think about that. You don't have to go into it, but I have some.
Can you repeat, Griff?
So when the proposals are paid out, when I say, hey, I want $100 to build a website, right? And then I make a milestone for $100, and then I build the website, and then I get paid the $100. Well, I'm actually getting DAI, of course, right? But I'm not actually getting DAI. I'm actually getting $100 worth of bonding curve tokens.
That you have to then withdraw yourself and pay the tribute on?
So yes, if I want to, I get to decide, do I want to hold those tokens? And then I get to vote, and I get to, maybe I'll be able to use my new tokens to actually persuade more proposals to go my way, right? So there's a value for me to have those tokens. But
are these called common stack tokens?
Commons tokens.
Commons tokens. Okay.
Yes.
Well, okay. I don't want to derail.
Let's call it if this is the token engineering commons, right? They would be tech tokens, token engineering commons tokens. These are the tokens of the system.
That's actually a good. That's a really good graphic. I don't think I saw it before. If you could send the link, that would be great. But you were saying, Griff, that once like a project is funded, you don't get the DAI, but you get tokens.
Yep.
Where
And
are
they,
those tokens coming from? They are minted, or they are so
They
the
are-
DAI actually in the funding pool is never touched.
well, the DAI in the funding pool will go to the reserve pool.
Okay.
So all of the DAI in the funding pool must end up going to the reserve pool again, and then turned into tokens. And then the person with the tokens can burn the tokens and get the DAI, but they have to
Oh,
pay you.
And why does that happen? Because you want to take the tribute?
We basically are wrapping an internal economy with with the augmented bonding curve. So we're creating this internal economy, but wrapping it in the bonding curve, so that if you ever want to interact with this system, with this commons, you have to do it through the commons tokens. You either receive commons tokens or you buy commons tokens, and commons tokens are the interface. And then internally we can protect and simulate and model this internal economy really well because of the boundary layer that we create.
You're protecting it from the crazy outside.
Yeah, exactly. We're just and then the commons itself, this internal economy, its value. If you have a lot of these, right? If you have an ecosystem of commons, you have imagine that we're replacing a local government with lots of commons, right? And you might have the streetlight commons, and you might have the roads commons, and you might have the public water commons and the electricity commons. Well, some of these may have different needs and demands, and the commons tokens can represent the market demand of these public goods. So that's at least when it comes to scale why this is especially important. You can now use market dynamics to determine and distribute like public goods based off of demand.
cool. Thanks.
But what I will say is that diving into the token bonding curve too much in this project will probably be more of a distraction because the what we have in the simulation right now is really focused on conviction building. Like all the outputs and inputs, it's like the token bonding curve is kind of hidden in there, and it's just held static, and we just assume some numbers, and then we start playing like in this one that Sam is showing. He's talking about alpha and how it shows what happens if alpha changes.
Do you think that we can, well, these are not interesting graphs, but we have some graphs, interesting ones here. And I would set just one output graph to make things simple for the people who visit the site. Like change a set of parameters and show one graph like we have in the augmented bonding curve webpage demo. I still don't. I am still not sure if this graph is interesting enough, but it is the most simple one because it doesn't use the network setting of the people who supports or not the the proposals, but because if not, if we, for example, use this one, like this one, we also have to show how people. This is something that random, and we also should have to show that at some point.
Yeah, I'm not sure. I'm not sure of the best output to show people. I think it really depends on what inputs. I think we have to choose the outputs and inputs together because we're gonna have we're gonna allow them to change some things, and then show them what the impact of the changes are, right? Like,
May I suggest a few that I put on my list and we discuss them and see if they make sense?
Okay, let's do that.
Yeah. Oh, there are some new ones. Interesting. Good. Behavior. The first one would be like, and it's quite basic, but would be the behavior of the price over time and depending on some actions. Like a few actions that I put, for example, like, okay, I know that after 6 months, we want to do this project and this project will cost 20K. I know that overall the monthly cost of maintaining the project would be 5K. And if I do that project at that time, that project at that time, and the agents are buying more or less, I don't know, like a random amount of token every month, what's the how does it behave? How does the price behave? See that over time. That would be the first thing. Also have a visualization of the size of the collateral over time. And that connects. Oh yeah, thank you. I was reading on another screen. And then that connects with actually question 4, which would have. Could we have a visualization of the health of the fund with some kind of, I don't know if a notation, but like, you do different actions. Those investors are behaving that way. How risky is it? Like, do those parameters have a chance to work? And the third one is, could we like put some parameters for the different agents and see if they work? Like, okay, if there is a really engaged investor, someone that puts money at the beginning and is gonna vote for all the project, is really wants to be involved. If you have a guy that is more like a speculator, or like what I call a lethargic agent, someone that bought and kind of like is never voting, is busy doing other things. And also an adversarial agent, like someone that would try, for example, to buy enough token to prevent the project from doing anything for some reason. I don't know if that's possible with the tool, but those are kind of like the outputs that I think would help people decide how they want to set up their commons fund. Does it make sense to everyone? Or
I mean, I think 3 is kind of more like an input, right? Like, what kind of investors do you have coming in, and then how does that affect some kind of output, which would be like, I mean, I guess visualizing the.
yeah, you're right. It's like, can I input the different behavior of the agent and then have as an output all the rest that I put?
I think that the third one is not being simulated. I think that the first one, we already have this with the, we have a graph with that, which is called summary of the local economy. And I think that we can get the collateral very easy. And I think that the agent behaviors, what we have is related with what people is going to vote, if they are going to vote on one proposal or another.
Yeah, I guess that connects to what you said earlier, Griff. Like for me, the voting part is less interesting. I'm more interested in the funds, the token bonding curve, and making sure that it's sound and that they would work with the parameters that we would choose. You said for the first one, I guess the behavior of the price over time, it would work. But could we also like add the actions towards the life? Like, okay, in 3 months, 20K is gonna be used for, or maybe have a simulation of a voting on a project, and if the project is voted yes, then that means 20K is extracted. Then we see what are the consequences of that. Does it make sense?
Yeah, I mean, actually, the three charts that Sam had before, where there was one that just went up, and then there were two that were stepped down with alpha.
Yeah.
That is actually kind of showing that, where it's like all of the sharp drop downs, all the steps are proposals being passed, spending money out of the funding pool. So I think that could definitely be and should be part of it, is like what, and the way it affects this system is that it affects the funding pool, right? And what the total amount of money is in the funding pool. That combines with the exit tribute for money coming in. So like you kind of have this like mix of when money goes out, it should actually at first decrease the funding pool and then maybe even increase the funding pool, because there'll be, if people cash out, there'll be the exit tax, the exit tribute. But yeah, we have to. I'm curious. I haven't dove in to really see how it visualizes that, or how it models the.
So it cut for a minute. You haven't seen what?
I haven't seen how it. I haven't really dove in to see how we can maybe play with those graphs, because like Sam was saying, it's only using alpha, and it's not. For instance, it's not using. I mean, we could. I wonder if we could just tweak instead of alpha, which maybe we want to parameterize alpha, but maybe sentiment, like, because in these three graphs, there above it there's the see if someone can find it. There's this is right, sensitivity, T-min, sentiment decay, right, base completion rate. These are all different things, and then you see he just put alpha as a parameter. Well, we could choose instead of saying, hey, let's see what happens when we change the sentiment decay, which is basically like how much do I care about this proposal the first time I hear about it compared to over time. How quickly do I forget about this proposal? I think that's what it means. And like we could start playing with some of these and seeing how that affects the funding pool. And like the tax rate is 2%. Well, that's really small, and that's probably why the funding pool is just like tanking, right? And never really growing. So maybe we need to up the funding rate.
It's growing, but it's growing very, very slow. So it actually makes the system unsustainable, because at the end you don't have much funds. So yeah, we could.
That would be something very useful, to see that. Like, okay, if I change this parameter, most likely your fund's gonna not survive over time. That's something that people will want to see. But then it would be great to also not only those parameters, but to have like I don't know, maybe just as a first step, like just at because we have the voting on some actions, right? If we could define the actual voting task, the subjects, just an amount, for example.
The amounts are definitely, I think they're basically randomized. So it kind of just like
Okay.
spits out a bunch of random amounts, and then also like here's a bunch of proposals, and then it maps every participant how much they like those proposals and how much money those proposals are. It kind of like populates all these data, all this data, and then runs it through to see what happens.
Okay, and then it shows the impact of like, okay, this 18,500 euros proposal for voted yes, that had you can see it in the curve or in the graph. Sorry.
Yeah, in fact, it would be really interesting to almost attach a narrative story, right? Like this proposal passed on this time, this proposal passed on that time, this proposal passed on that time.
Because in the end, that's what the end user people like me want to see is like, I wanna create this community, this fund, this group. Let's play with those parameters. Let's see what happens, and then because it's such a complicated subject. I mean, Jay said it, like so many words that even if you're in the field, you're like you need to read like for like 6 months before you even start to understand what's going on. But have some kind of some kind of storytelling, then it's easier to explain to people. Okay, we are creating this, and then you invest in that, and that's more or less how we will work.
Right, and you keep at the top of your mind, you know, it's both exploration and then explanation. When you're trying to explain it to the person that's using it, but you're also trying to give them a tool to play. So, and then I think in the end that some of the jargon has to kind of go away in the end. Otherwise, you're only going to have high priests using it. And I'm not sure that's what the commons would want you to have. I think you want the common people to be able to use it, not just the high priest.
Yeah, definitely. I think the main jargon that we have to own is like commons, patch, and I feel like there was one more.
Tribute, maybe.
Tribute, yeah, tribute's a good one. That's a mullet. That's a mullet term.
That's a mullet
and
word.
on top of that, the problem in I would add even to that is that it's different projects trying to do the same thing use different words. And it makes it, and sometimes they use the same word for different meaning. Like collateral doesn't always mean, like the same question you were asking, Jay, when you were saying what's the reserve, because in some case, like I guess in common stat case, and that's a really good point to know, the reserve is the collateral, but for example in Aragon case, the cash reserve is that's what you guys call the fund. So then that makes it super complicated to kind of like try to understand really what's going on, because it's different in each project, and it makes it harder to understand the whole field.
I'm totally joking when I say this, but what we should do is think of brand new words the way Maker did.
Yeah.
I mean, maybe I'm not totally kidding, but
I mean, that's why they do it, though, right? That's why they did it. Okay, so I let this thing. Okay. I let this go long. I think we had a productive call. Sam, did you have anything to finish?
Yeah.
Well, actually, I think we should just at least have our closing round, and we can chat a little bit after. But yeah, it's just, so closing round, just like final thoughts. Let me just say, I think this was very productive. Sam, thank you so much for going through the simulation. I learned a lot. And Jay and Nelson, thank you guys for diving in and contributing so much during the call in general. I think that we're like finally starting to work this in our head about how we can start making this work. And I'll be in Barcelona soon, actually with Sam and Nelson. So maybe we can have an in-person app on this.
That would be great.
Yeah, that
Yeah.
would be great.
I think it'd be really fun. Okay, and I will pass it to Nelson.
Awesome. Yeah, great call. Lots of things to kind of like now are connecting. Notably, I think one thing for me is that I wasn't sure before, and then I kind of like changed opinion, was that I wasn't sure if every bonding curve based project were kind of like using a similar way of working, similar formulas, similar structures. I thought they were different, and then I thought they were the same, and now I understand they're actually different. And there are very important differences that needs to be understood to be able to choose which one makes sense for whatever use case you wanna do. So thank you for the deep dive and the explanations. I think that's quite helpful. Then that means that I look forward to maybe enter more into the details of how Common Stack is doing the whole voting and bonding curve. And I guess that's what I will look at for the next week. I will pass it to Jay.
Hey, thank you. So I think for me, it was that chart that you showed of the whole system, and then in particular the feedback that comes back out of the reserve of the funding pool back into the token. And I think that feedback is maybe what makes it a complex system. So that kind of clicked a little bit for me, and I like that. I imagine that in this document, it also mentioned a white paper. So I think I might spend the next week maybe reading the white paper a little bit. Again, I've already read it once, but none of it sank in. So I'll pass it to Sam.
Okay.
Okay.
I think that we also have some more understanding of what's going on, and I think that we can play with those parameters of the simulation instead of playing with the parameters that we were thinking that were on other files, and see if we, for the next week, we have tested some different things and have different graphs that make sense to make a front end from them. So yeah, that's all. And has been a very productive call too, I think.
Sorry, I got kicked off again.
It's your turn, I think. It's disappearing again.